In this example, we're looking at Carlos playing college soccer. He makes a goal 65% of the time he shoots. Carlos is going to attempt 2 goals in a row in the next game. A is the event that Carlos is successful on his first attempt, and the probability of A is 0.65. B is the event that Carlos is successful also on his second attempt, or not also, but successful on his second attempt, which is probability of B is 0.65. Carlos tends to shoot in streaks. The probability that he makes the second goal, given that he made the first goal, is 0.90. Our first question in this example is, what is the probability he makes both goals? So we're looking for what is the probability that both A and B happen. So let's figure this out. We know that the probability of B happening given A is equal to 0.9. So we're going to use the general multiplication rule that was given to us in this chapter that says the probability of B given A times the probability of A. These numbers are given to us because we also know the probability of A is 0.6. So we're going to go ahead and multiply, 0.65. We're going to go ahead and multiply 0.9 times 0.65, which gives us the probability is 0.585. This means that Carlos makes his first and second goal with the probability of 0.585, or 58.5%. Now, letter B. The next part of this question asks, what is the probability that Carlos makes either the first goal or the second goal? The big word here is or. So we're looking for the probability of A happening or B happening. Now we have that formula for this. I'll write it underneath just like I did the other one. The general addition rule states that we can add the two probabilities. However, I need to take away that common area, which is P of A and B. Because if I include that extra area, just like in the very first set of examples I did, we would have repeaters. I think it was like 14, 16, and 18 on example 3.1 that were repeaters. So if I don't take away that extra area, I'm going to have more, like my probability is going to be higher, and that'll be wrong because it's supposed to be actually smaller. So we already know all three of these values. We know the probability of A is 0.65. We know the probability of B is also 0.65. And then I'm going to subtract P, A, and B, which is what we just found, which was 0.585. So I type that into a calculator and I get the number 0.715. So the probability that he's either going to make the first or the second goal is going to be 0.715 or 71.5% chance. All right, letter C. Letter C is asking us if A and B are independent. So I'm going to write independent with a question mark because that's what we're trying to decide. Are the two independent? So if you look in the section, it talks about independence. So first we want to find the probability of B and A. And we already found that the probability of B and A, or A and B, doesn't matter, is 0.585. Okay? We also know that the probability of B times the probability of A, if we multiply those two numbers together, I'll write it out, 0.65 times 0.65, we get the number 0.423. So to decide if these are, these two are independent, we compare these two numbers. Now, since the first number, probability of both B and A, is not equal to the second number, which is the probability of B times the probability of A, since these two are not the same, we would say that no, because they are not equal. So no, they are not independent. Letter D. Letter D asks us if A and B are mutually exclusive. Meaning, do they share a certain area? So we're going to check if A and B are mutually exclusive. So to be mutually exclusive, we have that probability of A and B happening has to be equal to 0. Now, because we have probability of A and B is 0.585, we know that this is not equal to 0, so no, these are not mutually exclusive. They do share a common area, and that common area is 0.585.